Hi, in 7.2, we were talking about multiplying and dividing rational expressions. Before we get started on multiplying and dividing the rational expressions, we need to look back a little bit. And that is, how do you multiply fractions? Right, we multiply the numerators together and we multiply the denominators. What we need to do first is a little bit of practice with this. So I want you to take this first set here and multiply and then simplify. And then in the second set, we're going to do it backwards. I want you to simplify first and then multiply. Okay, so pause the video and work through these two problems, then unpause it and check yours with mine. Okay, so for this first one, we multiply the numerators. 3 times 2 is 6, 4 times 5 is 20. We factor out the common factor. They each have a common factor of 2, so it'd be 2 times 3 and 2 times 10. Cancel out that factor equal to 1. We're left with 3 tens. Now in the second one, we do the same thing, multiply the numerators, but instead of multiplying, we're going to simplify first. We notice that 3 and 9 have a common factor of 3. So we have 3 times 4, and then I rewrote 9 is 3 times 3. Cancel out that factor equal to 1. We're left with 4/15. Now we're going to do that same idea, but we're going to be looking at something that has a little bit more going on with it. Not only do we have these coefficients, but we also have all these variable parts. What we want to do, though, is simplify before we multiply. We don't want to just take 5 times 6 to get 30 and 9 times 15 and then simplify from there. But rather, let's simplify first. So first thing we're going to do is we are going to rewrite it so our constant terms are first. And while we do that, we're also going to factor them. So we have 5 times, and we're going to use the 6, but instead of 6, let's rewrite it as 2 times 3. And then we're going to bring over all the x's. So we have the x squared and the x cubed, and then a y and a y squared. That's going to be our whole numerator. Now the denominator, we have 9, which we're going to change out to 3 times 3, and a 15, which I'm going to rewrite as 3 times 5. And then we have an x in the first fraction and an x in the second fraction, and then a y cubed and a y to the fourth. Now we need to go through and factor out those factors equal to 1. So we can cancel a 5 over a 5 because we know that 5 divided by 5 is equal to 1. We can also cancel a 3 for a 3. Looking at our coefficients, that's the only thing else we can cancel. We can't cancel a 2 with these 3's. So now, continuing with that idea, let's look at our x's. We have 2 here and 3 here, so there's 5 altogether. Well, we also have 2 down here. Well, if we have 2 right here and 2 right here, we can cancel 2 for 2 because we know that x squared is equal to x times x, which is what we canceled with this. Now, that's all we can do with the x. Now look at the y's. We have 1 y here, and this would be y squared, so this would be y times y times y. So that's 3 altogether, and we have y cubed here, so we can cancel y cubed, and then that would be equivalent to y cubed. So now we just multiply what we are left with. In the numerator, we have a 2 times x cubed divided by, and the denominator 3 times 3 is 9, and then y to the fourth. And that would be the simplified of that. All right, we're going to keep following the same process, but now we're going to be having more polynomials with more things that to factor and to simplify. The first step here, and you can see it, is to completely factor numerator and denominator. That's the one thing you have to do first, and it's going to make or break the problem. So first thing is completely factor numerator and denominator. I'm going to do one with you, and then I'll let you work on the rest. So number 1 here, we have to completely factor each numerator and denominator. Well, in the first fraction, we have x over x minus 2. Nothing there simplifies, so that just is x over x minus 2. However, in the next fraction, we have x squared minus 4. Well, that's a difference of squares, so that will factor into x plus 2 and x minus 2. And denominator, x squared, well, if you need to, you could rewrite that as x times x, or leave it as x squared. Now what we want to do is very similar to what we did in this problem. We want to cancel things out that are equal to a factor of 1. Now you'll notice that here we rewrote everything into one fraction. You could rewrite this all, but you don't have to. From here, though, we can cancel. We can say the factor of x minus 2 cancels with the factor of x minus 2. Also, we see that x cancels with an x. So what are we left with? In the numerator, we have an x plus 2 divided by x. Now the other question is can we cancel these two x's? And the answer is no, because this x is being added to a 2. You can only cancel factors. You may not cancel a term. So you can only cancel if it's being multiplied by something. Okay, what I want you to do is try number 2. So I want you to just do number 2 and then pause the video and check your answers. Okay, looking at number 2. First thing we have to do is factor. We notice that this is a difference of squares, which factors to 4x plus 3, 4x minus 3. The denominator, we have a GCF of 3x, so we can factor out the 3x. We're left with x minus 5. Now, since I factored out a 3 here, I also noticed that a 3 can be factored out as 6, so I rewrote 6 as 2 times 3, and then the 4x plus 3 in the denominator. So now we can cancel 4x plus 3 over 4x plus 3. Since this 3 is a factor, meaning it's being multiplied by the x, it's okay to cancel. If it's being multiplied, it's okay. Over here, it was being added, so it wasn't okay. And then we just multiply our numerators, we get this, and our denominator, we have that. Leave this in factored form, meaning do not distribute the 2 and the x. Leave it like this. Okay, now what I'd like you to do is move on to numbers 3 and 4. Again, pause the video when you're finished, unpause, and check your answers. Okay, for number 3, you should get x minus 1 over x times x plus 1. Number 4, you should get x plus 4 divided by x minus 4. Pause the video, look at my work if you have any questions, make sure you reach out if you do need extra help. Okay, moving on to the next. What we are looking at now is dividing rational expressions. Recall how to divide fractions. Well, first thing to do when we divide fractions is what it says right above that, multiply by the reciprocal. So we're going to take this and we're going to set up the 3 halves, but we're going to multiply by the reciprocal of the divisor. Keep in mind, reciprocal is when you switch the place of the numerator and denominator. And then from here, you multiply across 3 times 4 over 2 times 7. I also know that when we simplify, we know that we can simplify the factor of 2. So we could change this to 3 times 2 times 2 over 2 times 7. Factor out that factor equal to 1, and we'd be left with 6/7. Okay, before we move on to the next 4, we want to talk about reciprocals and what reciprocals are. We said it's when you change the numerator and denominator. So what I would like you to do now is work through letters A, B, C, and D here, and I want you to write the reciprocal of each of those. When you're done, unpause the video and check with mine. Okay, you can see all the reciprocals there. You'll notice what I did with letters B and D is I put a 1 underneath them just so I can see what the denominator is. The other thing I want to look at is letter C. Are we able to cancel these x's here? No, because in the numerator, the x is part of a sum. It's a term. It is not a factor. If it was being multiplied by the 7, then it would be okay. But here, we can't. Okay, so what we're going to do is divide and, if possible, simplify. Let's look at number 3 together, and then I'll look at you do numbers 1, 2, and 4 on your own. So looking at number 3, we want to multiply by the reciprocal. The first thing I do is I set it up as a multiplication problem, meaning I'm not going to factor anything this first step. Change it to multiplication and take the reciprocal, which would be x minus 1 over 2x minus 3. Now go ahead and we're just back to the problems like we did on the first page. Factor everything completely. Well, I know this denominator x squared minus 1 is a difference of squares. So this would be x plus 1 and x minus 1. I'm going to skip that numerator for a second and come back to it. And then I know this is x minus 1 and we have 2x minus 3. Now, this is probably something that might be the most difficult out of this problem to factor. What you can do is use the factors in your denominator as a guide because our goal is to get things to cancel. So chances are one of these 3 factors will be one of these. Well, it's probably not going to be x plus 1 or x minus 1 because we need to get a 6 and a 3. However, this factor right here might be helpful. So I'm going to actually use red here just so we can see, because this is us just doing some scratch work. If I use 2x minus 3 as a factor, and again, we brought that because we think that it might cancel with this. So can we multiply this factor by something that'll give us this? Well, let's start with 2x. 2x times what is going to give me 6x squared? Right, that's going to be 3x. Now we want to look at the other term here. Negative 3 times what gives me a negative 3? Right, that would just be a positive 1. So now what we want to do is check to make sure these two binomials multiply to give us the original here. And I'm just going to do some little work above it. 2x times 3x is going to be 6x squared. 2x times 1 is 2x. Negative 3 times 3x is negative 9x. Negative 3 times 1 is negative 3. And we know 2 and a negative 9 is negative 7x. And now you can see that this is the same thing that we're going for. So these would be our two factors that we need here. So from there, we can start canceling. I'm just going to keep with the yellow here so I don't get mixed up with the red. I have 2x minus 3, which cancels with 2x minus 3. X minus 1, x minus 1. And now we're left with the factors of 3x plus 1 over x plus 1. And you'll notice that I do not put them in parentheses because they are the only factors in the numerator and denominator. Okay, now what I'd like you to do is numbers 1, 2, and 4. Keep in mind number 4, we do not have a fraction as the divisor, but you can always put a 1 under it, just like I did up here in letters B and D. Okay, pause the video, try those out. When you're finished, unpause, check your answers. Okay, looking at number 1, we have to multiply by the reciprocal, and then we factor. And I notice that I have a 5 in this numerator, so I factor the 15 into 3 times 5 times x. Therefore, I can cancel the 5's. Again, you're able to cancel those 5's because this 5 down here is a factor. It is not a term. It's not being added or subtracted. Everything cancels out of the numerator, which leaves me with a 1 in the numerator. If you simply just had 12x, it would be incorrect. Also, if you had a 0 up here, it would be incorrect. If everything factors, you're left with a 1. And then we take 3x times 4 to give us 12x. Here, you would multiply them together because it's just monomials. If you have something with a binomial, you would not multiply them. So 1 over 12x. Number 2, pretty straightforward. We're left with x over 6. Now, looking at number 4, I didn't finish this one because I wanted to walk through it with you. We multiply by the reciprocal, which is what we get here. And then we know that this is a perfect square trinomial, so that factors into x plus 3, and then the x minus 4 in the denominator. We have the 1 in the numerator, but now we need to factor this. This one could be a little difficult because we have this 12 here, so you can use 1 and 12, 2 and 6, 3 and 4. But just like we said before, you can maybe use one of these as one of the factors down here in hopes that something will cancel. So we're going to do some sketch work. If we let one of these binomials be x plus 3, can we find another binomial here to multiply by that'll give us this expression right here? We think, okay, x times what is 3x squared? Well, that would be 3x because x times x needs to be 3x squared. 3 times what gives us negative 12? 3 times, and that would be negative 4. So what we want to do now is check this by multiplying it together to see if we multiply, we get this. So this is where we're going to do some work right underneath it. X times 3x is 3x squared. X times negative 4, negative 4x. 3 times 3x is 9x, and 3 times negative 4 is negative 12. Combine like terms, we get a positive 5x. So 3x squared plus a 5x minus 12. So therefore, this is the factorization of this. And then we go through and just cancel our like terms. So we have x plus 3 and an x plus 3. And looking at it, we see that's the only thing we can cancel. So therefore, our final answer is x plus 3 times 1, which is just x plus 3, multiplied by x minus 4 and 3x minus 4. Since they're both binomials, we do not multiply them, we just write their factors next to each other. Now, we might write it like this because this x minus 4 doesn't have parentheses. However, when we write it next to a binomial, we have to put it in parentheses, or else you would just be multiplying this 4 by those. And then that would be our final answer for this one. Now, we did not talk about checking your answers at all, but it's the same way we looked at 7.1. For example, if we were to type this whole division into our calculator into y1, and then type this simplified result into y2, the graphs should be the same and the y values should be the same. Okay, well go ahead and work at the 7-2 homework and let me know if you have any questions. Bye.